Today's first point, that is a deflection of indeterminate trusses. Okay, so first of all we have to clarify here that what is the meaning of determinate and indeterminate trusses. There are generally two types of trusses. First one is determinate truss, and second one is indeterminate truss. Okay, there are these two types of trusses as per structural analysis point of view. So whatever problems right now you have up till now we have seen, those are nothing but the problems on the determinate truss. Okay, now we have to first make clear that what is the meaning of this indeterminate truss, and after that we will see analysis of indeterminate truss. In mechanics part, you might have studied definition of perfect truss, okay, or imperfect truss or redundant truss. So at that in that subject of engineering mechanics, you have studied the formula, that is if your total number of members is equal to 2j minus 3, then if this satisfied, then your truss is perfect truss. Okay, so in mechanics you have used this 2j minus 3 formula, but there was some hidden meaning or hidden concepts are behind these values of 2 and this 3. Okay, so right now from here onwards, what you will do, we will modify this formula somewhat. And now first of all we will take this m is equal to, now we will modify this formula. M is equal to 2j minus r. Instead of 3 we will be writing here 2j minus r, where m is equal to number of members in truss, m is equal to number of members, okay, j is equal to total number of joints, and now we will where r will be total number of reactions in truss. Okay, so total number of reaction. So here what we will do, we know that there are three types of support. First one is a fixed support, then second one is a hinged support, and third one is a roller support. Okay, so fixed support is generally denoted by this sign, hinge support is denoted by triangle, and roller support is denoted by triangle and roller behind that. Okay, for fixed support there are three reactions. Okay, what are those three reactions? I will just show by using diagram. Okay, so for hinge support there are two reactions, and for roller support there is only one reaction. So let me draw these supports here. First we will go by fixed support. So whenever fixed support is there, so at fixed support there will be three reaction, one vertical reaction, one horizontal reaction, and one moment. Okay, so this is your fixed type of support. Okay, we have seen this in strength of material. Then we are having second type of support, that is hinge support. So for hinge support there are two reaction, one vertical and one horizontal. So this is your hinged support. Okay, and third type of support will be roller support. Okay, okay, so perpendicular to this reaction will be there. So if suppose your roller support is like this, which is making angle, some angle with horizontal, and if your roller support is like this, so in this case that reaction will act perpendicular to that plane of rolling. Okay, so this is in case of roller support, remember this. Okay, so why this I have again revised, because in this formula if you see m is equal to 2j minus r, in this formula of m is equal to 2j minus r, we have to put here directly number is equal to r, whatever number of reactions are acting in our entire given structure. So if this equation is satisfied, then and then only your truss is known as a perfect truss, or it is also known as a determinate truss. Okay, so this formula this formula of M is equal to 2j minus R. If it is satisfied, then your truss is determinate truss. Okay, remember this. If this formula is satisfied, then your truss is determinate truss. And if it is not satisfied, then your truss is going to be indeterminate one. Okay, so not satisfied, there will be two cases again. Okay, so M is equal to 2j minus R. This can be means from for both the sides of LHS of RHS, both values should be same. So in non-satisfied, there will be two cases. Okay, first case is equal to M is greater than 2j minus R. Okay, and second case, M is less than 2j minus R. Okay, so there will be these two cases, M is greater than 2j minus R and M is less than 2j minus R. Yes, if your M is greater than 2j minus R, then this truss is known as redundant truss. Okay, M is less than 2j minus R, then that truss is called as unstable truss. Okay, remember this. If M is less than 2j minus R, then that type of truss is called as unstable truss. So we will take one example of determinate truss of indeterminate truss, how to determine that. So let us take one example like this. There is a truss like this. One support is hinge, another support is roller. Okay, so we have to first determine whether this truss is determinate or indeterminate one. Okay, so determine, or rather than determine, we will write down find type of truss. Okay, so we know that formula is equal to M is equal to 2j minus R. Okay, so 7 members are there. How, if you count number of members, this will be 1 2 3 4 5 6 7. So 7 members are there. Number of joints I will show by green color. So this will be first 1 2 3 4 5. Okay, so 5 joints are there. So number of joints are 5. So at hinge support there will be one vertical reaction and one horizontal reaction, and at roller support there will be one vertical reaction. So total number of R is 3. So if you put here, so 2j, that is 2 times 5 minus 3, it is going to be 7. Okay, and which is equal to M. So now we can say that this truss is determinate truss. Okay, we can say that this truss is determinate truss. M is equal to 13, J is equal to 8, M13, J is equal to 8. What is R? R is equal to 3. Okay, so now if you take 2J minus R, so 2 times J, that is 8 to the 16 minus R3, so 16 minus 3, 13. So this truss is determinate one. Here I will write down just determinate. Okay, so this is the example of determinate truss. Now let us take another example. Find out whether this truss is determinate or indeterminate. Again same, M is equal to J is equal to and R is equal to. And remember, for this crossing, this will not be treated as a joint. Huh? This cross will not be treated as a joint. 1 2 3 4 5 6 7 8 9 10. Total number of M is here 10. Total number of joints 1 2 3 4 5 6. Total number of joints are 6, and reactions again, one vertical horizontal at hinge support and one vertical at roller support. So reactions are 3. So now if you take this 2 times joint, so it is going to be 6 into 2. Now here if you take this M10 and 2 times joint, 2 into 6 minus 3. Okay, so it is going to be 9. So 10. So now here M is greater than 2j minus r. Okay, so this truss is going to be indeterminate one, and in that also it is going to be redundant truss. Okay, remember this truss is redundant truss, and total, and it is redundant by how much number? It is redundant by only one number. That means this m is by one unit, it is greater than 2j minus r. So now here degree of indeterminacy, or it is also denoted by di, it is going to be 1. Okay, so here I am introducing one new concept, that is degree of indeterminacy, which is equal to 1. So how I have come up with this formula? So here m is greater than by 2j minus r by only count of 1. So this is di is equal to 1, or in other words, if you take this formula for di is equal to m plus r minus 2j. So this will give us degree of indeterminacy for indeterminate truss. Okay, so now if you want to directly find out degree of indeterminacy for this given problem, if you put m is equal to 10 here, okay, plus r is equal to 3 minus 2 into 6. So this is going to be 13 minus 12. So this is going to be 1. Okay, so this degree of indeterminacy for this particular truss is equal to 1. Okay, so now that this means this truss is indeterminate to first degree. Indeterminacy for determinate truss will be 0, always 0. Remember this. So find out degree of indeterminacy. If you see m is equal to here 1, 2, 3, 4, 5, 6. Okay, then total number of joints 1, 1, 2, 3, 4, 5, and total number of reactions R is going to be 3. So now if you put in that our formula, initial formula, so m is 6, and if you take 2j minus r, so joints are 2 into 5 minus 3, so it is going to be 7, and which is greater than m, that is m is equal to 6. Okay, and now if you find out degree of indeterminacy, so degree of indeterminacy is going to be m plus r minus 2j. So m is 6 plus r is here 3 minus 2 into j, that is 5. So that is going to be minus 1. So this is, you have to, this is one new concept, that is for unstable truss degree of indeterminacy will be always negative. Remember this. For unstable truss degree of indeterminacy will be always negative. Let's take one typical example. So total number of member 1, 2, 3, 4, 5, 6. So m is equal to 6. Total number of joint 1, 2, 3, 4. So joints are equal to 4, and reactions are now going to be 1, 2. This is 3. R is going to be 3. So we are having formula for di is equal to m plus r minus 2j. So m is 6 plus r is 3 minus 2 into joints. So this will be 9 minus 8, that is 1. So this is truss is indeterminate to first degree. Okay, so m, first of all we will calculate m. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So m is equal to 15. Then j, joints 1, 2, 3, 4, 5, 6, 7, 8. Joints are 8. Okay, and total reactions 3. R is equal to 3. So we are having formula for di is equal to m plus r minus 2j. So m is 15 plus r is 3 minus 2 into 8. Okay, so 18 minus 16, it is going to be 2. For this case, degree of indeterminacy is equal to. Okay, so we will take this example once again. Okay, so and remember here, this particular example is of determinate type. So I will just tweak this problem. For this particular case, find out degree of indeterminacy. So for this problem, di is equal to 1. Here I will write down it. Now same problem, okay. Just please observe how I am modifying this problem. So for this problem, what was degree of indeterminacy, which we have previously solved? For this problem, we have taken degree of indeterminacy is equal to 0. Why? Because total number of members are equal to 2j minus r, or m plus r is minus 2j is equal to 0 for degree of indeterminacy is equal to 0 for this case. We have seen first variation of this problem, that is where degree of indeterminacy is equal to 0 for this case. Okay, then we have also seen this second variation where degree of indeterminacy is equal to 1, and in between these two we will see one another problem. For this particular case, this is first case, this is second case, and this I will write down as a third case. Okay, in first case degree of indeterminacy is 0. This case degree of indeterminacy is equal to 1. Here case number 1 is the case of determinate structure. Okay, is it clear? It is clear to us that case number 1 is the case of determinate structure. Now case number 2 and case number 3 both are the cases of indeterminate structure, and indeterminacy value is also same. But what is the difference here in case number 2 and case number 3? Remember, now let us talk about example number 2 here. So here our truss is indeterminate due to this presence of one extra member. Okay, in this case number 2, this truss is indeterminate due to this presence of one extra diagonal member, which is internal member again. So here we will say this truss is internally indeterminate. This truss is internally indeterminate. Whereas if you see in case number 3, there is one extra reaction, external reaction is there. Okay, in case number 3 there is one extra external reaction is there. Therefore this truss is externally indeterminate. Okay, so this is the difference between these two cases. This case number 2, this truss is indeterminate due to this internal member force. This is internal member force. And in this case, this truss is indeterminate due to external reaction. That means there will be 4 reactions. Okay, so due to one extra reaction, let us say this one extra reaction, this truss is indeterminate. And in this case, this due to internal member, this truss is indeterminate. So there are two types of again indeterminate trusses: externally indeterminate or internally indeterminate. Both type of cases can be there. Okay, so now again we will see fourth variation of this particular case. M is 8 and j is 5. Okay, so if you observe here, total number of reactions I will just plot. Okay, and total number of members are also here. So if you observe, here is one extra reaction is there, and also there is a presence of one extra internal member. So this truss is both internally and externally indeterminate. Remember this. If, or just in short, remember, if your truss is having more than 3 reaction, if it is 3 reaction, then it is okay. There, that truss is not never going to be externally indeterminate. If your reactions are more than 3, which is this case, your reactions are 4, then your truss is always going to be externally indeterminate. And in addition to that, if you take example of this problem, here total number of reactions are 4 and our degree of indeterminacy is 2 here in this case. Okay, so that 1 degree of indeterminacy is coming from this external reaction and one extra is coming from this internal member. Okay, so whenever this type of cases are there, so this stress is internally and externally, both type of indeterminacy is there. Whereas in previous problem, if you see in this problem, only external indeterminacy is there in case number 3. In case number 2, only internal indeterminacy is there.